So today we're going to learn about ternary ionic compounds. We will learn how to name them and write formulas for those compounds. Ternary just means at least 3 elements. Okay, so 3 different elements will make up this compound. And how are we going to tell that there's 3 different elements or more? What are you going to look for?
Capital letters.
Okay, so you're looking for the capital letters. So ionic compounds are still made up of 1 cation plus 1 anion. So that means if there's going to be something with multiple elements, it means there's going to be a polyatomic ion in that name or formula. So we're going to learn how to write formulas for the ternary ionic compounds first. If you are a step person, if writing out the steps is helpful, write these steps out. Okay. If you are a learn by doing person, we'll do some examples on the next 2 slides, and we will go through those steps as we do them. Okay. So our steps are pretty much the same thing as our binary ionic compounds. Okay. We're still going to write the formula for each ion. Okay, so we'll write the symbol and the charge. Then we still have to balance the charges. We'll do the crisscross rule for that. Okay. The only differences are we have to be able to recognize that there's a polyatomic ion in the name. Okay. So most of the time, the polyatomic ion is going to end in ite or ate. So if the word ends in ite or ate, that's going to be your big indicator that it's not just a single element from the periodic table. Instead, it's a polyatomic ion, where we're going to find it on the back side of our periodic tables. Okay. There are a couple exceptions to this rule. Okay. So like hydroxide and cyanide, they end in ides, but they're polyatomic ions. Okay. There's like ammonium. Okay, so a couple exceptions, but for the most part, if you see ite or ate, that's your indicator it's a polyatomic ion. And then sometimes when we write formulas, the polyatomic ion needs to be in parentheses, and I'll show you in our examples when and why it needs to be in parentheses. All right, so I give you the name calcium nitrate, and we're going to write the formula. So pretty much the same technique as we did with the binary ones. So what's the symbol for calcium? And what's the charge? Okay, 2 plus. Then nitrate. What gives it away in nitrate that should tell you you need to find it on the back? Okay, 8. If you see that it's ending in ite or ate, it is not an element on the periodic table. It's going to be a polyatomic ion. Okay. So then go on the back side, find nitrate. And then once you find it, tell me what the formula is. Okay, so go ahead and take your time to find it, but you should be finding NO3 with the -1 charge. Okay, so now we have our charges. What do we do next? Crisscross. And then just a reminder, only the numbers. Okay, no charges. So we end up with Ca1, NO3, 2, and then now, do you see how it now looks like NO32? Do you see? Okay, if you're going to add a subscript after the polyatomic ion, you have to add parentheses around the entire polyatomic ion. All right, and then finally, do we usually write 1 as a subscript?
No.
Okay, so I'm just going to rewrite it as Ca NO3 in parentheses 2. Okay, we're going to do 4 more together. Our first one is strontium sulfate. What's the symbol and charge for strontium? Okay, strontium SR, what kind of charge does it have? Okay, +2. All right, and then sulfate. Where are you going to find the formula for sulfate? Okay, back. So look for sulfate. What are we finding for the formula?
SO4 2 charge.
Good. Okay, SO4 2 minus. Okay, so we have our charges. What's our next step? Okay, crisscross. So we end up with SR2 SO4 2. What needs to go around the SO4? Okay, so anytime you add a subscript other than 1, you have to put parentheses around your polyatomic ion. Okay, and then everyone pay attention to this next step. Remember from Monday we talked about if your subscripts can reduce, do you have to reduce them?
Yes.
Okay, when it comes to reducing subscripts, it is only the ones from the crisscross rule. Okay, so I'm going to highlight the ones that we can reduce. Okay, you may not touch the polyatomic ion subscript. Okay, sulfate is SO4. If you change that 4, you change what it actually is. Okay, so you may not touch that subscript. Only the subscripts you get from crisscross. Does that make sense?
So
Okay.
Is it safe to assume that sometimes you don't change the ones that are in the parentheses?
Never change those ones. Okay, so the 2's reduce and it really just becomes SR, SO4. Okay, let's look at copper 2 sulfate. What's the symbol for copper? And what kind of charge does this one have? 2. How do we know it's a +2? Okay, remember, it's telling you in the name. Okay. All right, and then sulfate, did we just look this one up? Okay. So it's SO4 2 minus. What's the next step? Okay, crisscross. So we get Cu2, SO4 2. What needs to go around the SO4?
Parentheses, but we can also.
Parentheses.
Subscripts.
Okay. Can our subscripts be reduced? Yes? Can you reduce the 4?
No.
No.
Touch the 4.
You may not touch that one. It changes the whole chemical structure. Okay. All right. So what's our final answer for copper 2 sulfate? Good. All right. So copper sulfate is CuSO4. All right, next we have sodium cyanide. What's the formula for sodium? Na, what kind of charge? All right, and then cyanide, it ends in IDE. However, if you were to look at the periodic table, are you going to find cyanide anywhere? Okay, so if you are looking everywhere for it and you don't see it, that's going to indicate it's going to be a polyatomic ion. So even though cyanide ends in IDE, it's actually a polyatomic ion. Okay. So take a look on the back side. Have you found cyanide yet? Okay. What's the formula? Okay. Cn, -1 charge. Okay. All right. So we have our charges. What's the next step? Okay. Crisscross. We end up with Na1, Cn1. Do we write the ones?
No.
Okay, so we're just going to write this one as NaCN. All right, and then last we have calcium acetate. What's calcium? All right, and then acetate, if you look at it on the polyatomic ion chart, do you see how there's 2 options? Yeah. Okay, either option is fine. If you count the number of carbons, hydrogens, oxygen, notice they're the same. Okay, the first one is the more structural formula. The second one is just condensing them. Okay, so you may pick whichever one you like. I tend to go the C2H3O2. That's just how I remember it better. But if you chose the CH3COO, that one's also fine. All right, after you write your charges, what do? Okay, crisscross. So you should end up with Ca1, C2H3O2, 2. And what needs to go around the acetate?
Parentheses.
Okay, parentheses. And then I'm just going to rewrite it without the 1. Okay, so that's one option. Let me show you if you chose the other option. You could have done Ca2 plus with CH3COO. Okay. Let me show you this one because I want you to be careful with this. Okay, if you chose this one and you put the 2 there, do you still need parentheses around the acetate? Yes. Okay. Anytime you're adding a subscript after the polyatomic ion, you need parentheses. By adding the parentheses, it's meaning you need 2 of this entire thing. Okay. Without parentheses, it's just saying you only need 2 of those oxygens. Okay. So anytime you have to add a subscript other than 1, parentheses always goes around your polyatomic ion. The last thing we're going to do is just naming. Naming the ternary ionic compounds is pretty much the same thing as the binary ones. Okay. So the first thing is you have to recognize that there's a polyatomic ion in your formula first. Okay. And again, ionic compounds are always just 2 parts. There's always a cation and always an anion. Okay. So then if there's a polyatomic ion, there's going to be at least 3 elements. I'm going to say 3 plus elements. Okay. And how can you tell elements apart?
Capital letters.
Capital letters. Okay. So if you notice that there's at least 3 capital letters, it's telling you one of the either the cation or the anion's the polyatomic ion. Okay. Most of the time, it's always like the anion. Okay. So then we just name the cation first, and then we name the anion. Okay. So, for example, we have NaC2H3O2. Okay. How many elements are in that formula? Okay, 4. So it's more than 2, so we know one of them has to be a polyatomic ion. This gets better with experience. Okay, the more we look at them, the easier it gets. Okay. Usually, the first element is just a single element. Okay, so our cation is going to be sodium. And then what's remaining, your anion, is usually the polyatomic ion. Okay, so that means the C2H3O2 is all one thing. So now we just look up the names. So the name of Na is sodium. And then you would look up C2H3O2 on your chart. Okay, and so if you look it up, what's the name? Acetate. Okay, one thing to notice, polyatomic ion names don't change. Okay, so we don't change the ending like we do elements. It is exactly how you read it on your chart. Okay, we're going to do 2 practice problems. So here I give you the formulas, and we're just going to write the names. So our first one is CuClO2. Okay. What question do you ask yourself every single time when you look at the metal?
Transition.
Okay, is it a transition metal? And is copper a transition metal? Yes. So, yes, you have to write the charge. Okay. And we figure out the charge the same way we did on the binaries. So we just look at the anion. Okay, so the anion is ClO2. Okay. So find that on your naming chart. Okay. What is the charge of chlorite? Good. Okay. So chlorite has a -1. And then the quantity of chloride is on the outside of that parentheses. So how many chlorides are there? 2. So what's 2 times -1? Okay. So what kind of charge does copper have to balance that? Okay. So then copper is going to be copper 2. And then what do we call ClO2? Okay. Chlorite. And again, for these ones, they're almost easier because you don't have to change the ending. Okay, it's just however you see it on the periodic table. Okay, our second one is Na3PO4. What's the question you ask yourself? Okay, is sodium a transition metal? No, so do you have to figure out the charge? Nope. So what do we just call Na? Sodium. And then we look at PO4, and what do we call PO4? Phosphate.